Well, thank you very much for the invitation and introduction, Jacqueline. I didn't bring any heat along with me, but I think you'll take care of that. As Jacqueline said, I've been in this business for a long time, mostly at Cornell University. And along the way, I kind of stumbled onto this kind of information, to be honest about it. I wasn't really prepared for it. I was on the other side of the fence. But nonetheless, the information spoke for itself. And as I got into this, I discovered there's a lot of resistance to this idea. So in terms of the resistance, I should say, probably the single most important thing that I can think of, nutritionally speaking, is the question concerning animal protein. Animal protein, not plant protein, very different. Animal protein, of course, is what people want around the world. Make no mistake about that. That's what they want. And it leads to a huge industry, as you know. I might just by way of introduction, say something here. You know, we've got a government, for example, that one department of the government, the United States Department of Agriculture, for example, they are very much into the livestock industry. People that do that, and they get sick. A lot more people get sick by doing it that way. But then when we get sick, we got another department in the government that's got all the drugs. That's Health and Human Services. So just by way of introduction, I'll come back to that in a moment. What really interests me, though, is this question concerning protein. Why do we think protein is so important? Protein is important. We need some protein. That's not the issue. But why do we think about protein in the context of, let's say, animal protein in particular, which is said to be high quality? You know, whether we think about that subconsciously or consciously or don't even know it, the fact of the matter is what drives the discussion in the world, quite frankly, more than any other single thing about nutrition. The thing that really drives the discussion and thinking about this question probably is this idea, should we eat animal protein? Okay, let's have a look at that. I hope I don't get too deep into the science here on this day, but make you struggle and try to understand and get warm, possibly. In any case, it's kind of ironic that I'm standing here now, because I've spoken in Syracuse a number of times over the years, mostly at the medical center, but I was here one time many years ago. Now, just about, 60-some years ago, but late 1960s, it was association with the meeting, the conference being held by the livestock farmers of New York State. It was a cooperative extension of their national meetings, and I was coming along. I was asked to come and speak at that, and so I was on the other side of the fence. I was on the other side of the fence because I did my graduate research at Cornell University, my doctoral dissertation actually, on a topic that was intended to advance, if you will, the consumption of more animal protein. So I was in that camp. In any case, I came from a farm. I'll come back to that later. It was all natural for me. That's what I did my research in, and so forth and so on. So I learned what I learned primarily from the other side of the fence, and kind of had to struggle to get into this sort of territory. And so it's really all about the science. I'm in science, obviously, and I didn't get into this idea for any other reason than simply just working in the laboratory, lecturing, of course, a lot, and just learning stuff as we're going along. And that's how I got to this idea, if you will. I'm going to take it back a few years and just sort of mention this to you for starters. This man here, lived in the 1800s, was a fairly well-known scientist in Denmark, and he is the one who, quote unquote, discovered protein. What does that mean? He was actually working with dogs at the time. I think one or two. I mean, it was very minimal research, but he was working with a dog who liked to eat meat, and so he wanted to know, you know, and the dog had to survive, according to his observation, if they had meat. So he became interested. What's in that meat could we identify something in the meat? And he came up with a chemical. He isolated in that meat, and that chemical alone helped to sustain the dog's life. So the chemical in that meat was really pretty significant, to say the least. So he gave it a name. It gave it a name that then lived with us ever since then. That was in 1839 when he made that discovery. So this has been around a long time. And the whole history of protein from that time forward is really quite fascinating. I mean, there's a lot of politics, there's psychology, science, medicine, etc., etc. So he needed to name the word something, the chemical he isolated, and so he named it after the Greek word, proteos, P-R-O-T-E-I-O-S. Has anyone ever heard that before? The origin of the word? Oh yes, there's one person on the back. So in any case, that word in the Greek language meant first. It meant of primary importance. And so another colleague of his at that time said, hey, this is the stuff of civilization itself. So it took on a reputation, if you will, of something really, really important. Kept the dogs alive. Later it was shown, of course, to stimulate the growth of pigs, and unfortunately humans to some extent too. So the Greek word, proteos, protein, that means of prime importance. And over the years, what has happened as this idea became embedded in our thinking and our whole system, it turns out, as we look back, protein as a nutrient, animal protein that is, has been so significant. I call it the driver nutrient. It has been the primary motivation as poor countries, get into more money, they want to eat the good kind of food, and so forth and so on. The idea of making sure we get the protein from animals, by the way, not from plants. In the beginning, it wasn't known that protein was in plants. So in any case, that's really what drove dietary choice. And as we see countries change over the years, over decades, even a century or more, as they consume more and more protein, they get in more and more trouble, more and more animal protein. And that's what I really want to consider with you is, what do I mean more trouble? I call it animal protein the driver nutrient, the single most important nutrient of all in terms of its influence. No question about it. People want that, and it turns out there's I don't want to get into this too deeply because it's a little longer story, but it turns out that idea of consuming animal protein was so attractive to them at the time because they already had it in their minds that we had a right and almost a responsibility, in a sense, to eat animals. That's what it really meant. And so, in a sense, that discovery gave justification. It gave justification to eating meat. Hey, that's got the thing in it that really makes a difference. So it kind of took on that sense. And so when poor countries, not having much money, for example, when they start getting money, then one of the first things they want to do is to get some of that good food, if you will. And it turns out that getting into that kind of discussion and actually discovering, as I have in my own career, that's a problem. It's a serious problem. So when I started talking about this a bit, I was getting into trouble. I was at Virginia Tech at first, but then I was at Cornell since 1975. And I was actually in the department, the animal husbandry department, of all places. In fact, I think the first talk I gave in Syracuse, I've given a number over the years, but mostly at the medical center. The first talk I gave here was at the farm days, if you will. There was this meeting with the farmers in the state, as I mentioned before. And my friend, at the time, a young faculty member, I talked, and I don't even remember what I said, but I was sort of talking about my research and stuff like this. I said something that, hey, maybe things aren't quite as much as what we think they are. He scolded me after I got off the podium. He said, I can't believe you said what you said. And of course, I was talking to livestock farmers. So I was kind of introduced at that point in time, hey, there's something here, but pay attention to it. And so as the years unfolded, And with myself coming from the dairy farm, milking cows, growing up doing that, and being a farm boy all the way around, I have seen the changes that occurred since those early days. And so, and I've become concerned about this question of eating so much animal protein. I'll show you why in a moment. Yet, people still want it. People still want it. And so this is some pictures off the web, if you will, the factory farm operations, as you know. And so now we have an enormous business in the world of eating as much animal food as we possibly can. And what's really interesting about this? I would have hoped, maybe thinking, in brighter days, I would have thought, maybe with this information getting out there and becoming very public, that more people would begin to understand that eating animals is not exactly the right thing to do to get that protein, if you will. And so what we find on the internet, if you look on there yourself, the discussion about eating meat as a desire, the discussion today really has to do with how can we meet the future demand for protein, and that means animal protein. That's where we are in the world. Somehow people have a really hard time of trying to even listen to this kind of information. They still want to eat meat, and that drives, of course, a huge industry. And so on that point, as I mentioned before, here's a plot from, I forget where, the World Bank actually, showing the relationship between how much protein we eat. That's on the y-axis, over the left-hand side. This is the amount of protein we tend to eat as a function of, on the bottom axis, the x-axis, as a function of GDP per capita. In other words, what this shows is a bunch of different countries here who, as they get more money and development and become more affluent, etc., there's a straight line relationship. That's really impressive. That's no mistake about it. Income is directly associated with the ability to consume protein. And people, as I said, they want to consume animal protein because that makes you big and strong and everything else. And so that's what it turns out to be when you compare these countries. Now, I've had a chance to actually speak in a number of these countries, and I've seen it from the countries who don't have an opportunity to consume protein, and that's the first thing they tell me. That's the first thing they want to do. Poor countries. When we get the money, we want to be rich like you in the West, and the first thing that comes to their mind is eating animal food. That's the ticket to heaven, almost. It's nothing short of that, quite frankly. More money, eat protein. And by the way, of course, most people think that protein only comes from animals, at least for some years after 1839 until maybe late 1800s, people thought it was only animals. And then sort of discovered plants had protein too. Then somebody came along, some scientists, in the early 1900s, I'll show you in a moment. They wanted to create a scientific method to show that, oh yeah, okay, plants have protein, but that's low quality. That's what it was. And so then we had to we have lived with until the present day. That when we talk about protein, okay, people acknowledge that, there's enough protein in plants, but that's bad. That's not good quality. So there's just this deep-seated belief that we need to go to the question concerning quality. I mean, who would not want high-quality protein? I mean, if you got this kind of protein from animals, high quality, this is low quality, who doesn't want high quality? So it kind of adds to the sort of the conversation that goes on. So let's look at this question concerning high quality. Where did that come from? This is in the early 1900s, and technically, high quality protein means that when we consume different kinds of proteins, the proteins that is best retained by the body, with percent retention, the protein is best retained in the body, it turns out to be all animal proteins. Whether we're talking about milk and its protein, eggs, meat, whatever the case may be. The protein from animals suits our needs. It's only reasonable. We're animals too. And so when we eat other animal foods, and we get the protein out of that, the composition of that animal protein is such that it absorbs faster. That's only common sense. I mean, we're eating like versus like, if you will. And so it hangs around. But that doesn't mean it's good. But they use that kind of observation to say, oh, this is high quality. So all the animal proteins, when you compare all the animal proteins, and this has been done in some systems, you compare all the animal proteins and all the plant proteins, all the animal proteins are high quality. All the plant proteins are not. So we're still stuck in that same rut, believing that protein, even though it's present in plants, is said to be higher quality. I'm going to say it's not. It's absolutely not. I lived with this myself when I was doing my doctoral dissertation, living with the idea that, we're doing something important here. We're figuring out a way to, produce more animal protein. So animal proteins have high quality, plant proteins, low quality. So where'd that come from? Looking at the history of these kind of questions sometimes are really interesting, because it kind of begins to tell us, where our biases may be and that sort of thing. So it's higher retention of the protein, it means higher quality. And that was determined by a man by the name of H.H. Mitchell. He's a professor at the University of Illinois back in the 1920s and 19-teens. And so retaining, as he learned at that time, retaining more protein, that's good, because it makes pigs grow faster. And it makes animals grow faster. The studies were done in rats, actually, but when you grow faster, everybody wants to grow big, right? And that's the kind of thought that's existed around the world. We're supposedly big because we eat animal protein. So in rural China, for example, where I spent many years off and on, they tend to be smaller and so forth and so on. That was what they wanted to do. They wanted to get big so they could be in the Olympics one day, and they did get into the Olympics, and they wanted to be able to compete. So that thought was around. By the way, Mitchell, 10 years before that, was participating in a discussion with some other scientists, 1913, a discussion about, that animal protein was really important, and it really related to racial superiority. So believe it or not, there was a discussion in 1913 that the inferior races of the world were inferior because they weren't consuming animal proteins. That's simple. That's how deeply profound. That's how profound this idea has become in our sort of consciousness, and from many different points of view. So I'm going to point out here quickly, it turns out, and this is most of our own research that I was involved in the lab with my students and so forth and colleagues, it turns out more protein being retained, it sounds like a good idea, but in a sense, here's what else it does. You retain more for protein. It also increases the production of growth hormone. When you produce more growth hormone, that causes cancer to go faster. You do something else, and for women, blood estrogen levels rise. And blood estrogen, the higher levels of estrogen in a woman's blood, the higher is her risk for breast cancer and uterine cancer as she goes forward. And then it does some other things. You do all these things here. I just showed you things in the top. I don't want to get the details of that. But basically, higher retention, animal protein, right, means more cancer. It's that simple. That's the basic structure of some of the science. My colleagues, by the way, don't like to get into this. This is getting into territory here that they consider to be really kind of dangerous. This is so profound when you begin to realize this. You really ask yourself, why would I ever want to eat animal protein? Okay, so animal protein does something else. Animal protein does something else. It increases the amount of cholesterol in our blood, which in turn has serum cholesterol. The higher the serum cholesterol, the higher the heart disease. So more animal protein means higher risk for heart disease. So you get more cancer, greater chance for cancer, more risk for heart disease, and at the same time it does some other things. It changes some things in this system too that relate to a higher risk for diabetes. There you have it. There's the package. The package for Western rich nations. More animal protein. Okay, more animal protein, more cancer, more heart disease, more diabetes, you name it. And I might add also, I can come back to maybe one time to it, but I'll say it anyhow because it's germane. The more serious is the result of getting COVID-19. It's that simple. This work we did in China as well. It's very powerful in terms of its effect on viral diseases as well. So this all becomes hopelessly complex. There are so many nutrients, there's so many this, so many that, everything. The public is obviously going to be confused. So are the professionals. So are the professionals. And that's what happens in the public at large. That's why, for example, veganism, vegetarianism, the kind of thing like that, struggles to be heard. Because it's not really based on good science, to be honest about it. And so what happens, if that's the only selling point, we're not going to be making too much progress. So it all results from the basic science. If we know the science, we can move, we can make decisions without a doubt, without having any doubt in mind. And so, okay, all that complexity is out there. I'd like to think that somehow we need to find ways to, let's just simplify this. Let's simplify it. And my best guess, to be in this field as long as I have, there's two recommendations, and you know what? You don't need to know much more than this. So for those who are not interested in science and don't understand the science, what are just two things? Consume plants. We have no need for animal protein, zero. In fact, when you start consuming animal protein, you get these results that I just showed you a moment ago. So consume plants, that's item number one. Item number two, try to consume the plants as much as possible in the whole food form. When you take out the sugar out of plants, in the plants it's okay, like in fruit and stuff like that. You take it out and put it in a bowl, you know what we do with that. And so at the same time, if you take out the fat or whatever, take out this nutrient, that nutrient, something else, where all the confusion is, I'm going to try this, I'm going to try that, something else. Well, it turns out all the substance in plants all feed into a system of creating health. Okay? Stuff in animal food, mainly protein, feeds into a system that creates disease. So I say two things. Consume a diet that is plant-based. Okay? I actually came up with that expression myself back in the late 1970s, and I was on a government panel at the time, and I wanted to say that in order to avoid, to be honest about it. I was on a panel with a bunch of cancer researchers, and they wanted me to talk a little bit about protein because they were oncologists and pathologists and so forth and so on. So I didn't want to use the word vegetarian in those days, to be honest about it. No offense to anybody here about vegetarianism, but I didn't want to use that name because that name actually has not spread very fast, very far in the world. The only way we're going to get this under our belts and get to recognize what this does is to start talking about it in a context of serious science. Most vegetarians, vegans certainly, we have good records on it. Vegetarians and vegans, their diet is not that much better than the carnivores. Because what they're doing, they're not eating animal food, that's okay, that's out, that's a good thing, it's a step forward. But what they end up doing is eating a lot of salt, sugar, and fat. And it's exactly the same as what the meat eaters have. So, vegetarians, vegans are, okay, they're taking a step in the right direction in many ways, but they're not seeing the real gain that can be had by just, kind of sticking with the idea of not consuming animals. That's number one. Number two, all the synthetic foods, if you will, that have been concocted and dumped in there with oil and fat and this and that problem. So that I say whole food, plant-based diet. By the way, this is something here we tend not to know. I guess we don't know. When we consume less animal food, that's a gain, right? We're consuming more plant food. The two just like a seesaw. So when we see these relationships between animal and plant food, we have to keep in mind those effects are occurring because of two things. It's either, on the one hand, the hazards of consuming animal food. At the same time, we're increasing the good stuff in plant food. Antioxidants and vitamins and stuff like that, fiber, etc. So we got 2 for 1 actually creating the same effect. Okay, I'm going to add another little picture here, the one that had my thesis. I really got into this field, and those of you with the China study, I'll go over this pretty fast because I got into it because when I first had my first faculty position at Virginia Tech in Virginia, I was put in charge, or I was the coordinator of a State Department project we had in the Philippines, feeding malnourished children. That was quite an experience, I must tell you. Once you have seen malnourished children and children dying, you don't forget that. And one of the things about the program we had in the Philippines was to make sure, and this is what we all thought, and everybody said this, make sure these kids got enough protein. And that meant animal protein, good quality, okay? And so that was the idea. We're going to create a nationwide program for, helping develop a system by which these children could get more protein. But I saw something that was rather surprising. I got the impression that the children consuming the most protein, not many, they had a higher risk for getting liver cancer. I said, wait a minute, there's something crazy here. I didn't believe it. And mind you, I'm coming from my background. That's why I say my own graduate research was promoting animal protein. And here this was, these kids getting animal protein. So, and then we're supposed to be getting more animal protein in these kids. I have a problem. How could you rationalize this? We're supposed to give it, that's the government orders almost. They were selling dried milk powder in the Philippines. That's what was a market for dried milk powder. Lots of protein. And so to see that, I only had one choice. Now, so you come back to the lab and organize an effort to see if this is true. Is it true that higher animal protein might cause cancer? And that's really where I sort of got my operation going. I got money from the government, the NIH, if you will. That continued for the next 40 years, actually, and gave me a chance to look at this question in great depth. Does animal protein really give rise to cancer? Here's about that time in 1968. Here's some Indian workers who did a little rat study, and they had two groups. And what they did, all these rats had exposed to a carcinogen that gives rise to liver cancer. Okay, they fed one group 20% protein. That's the high level, and the other group lower. And they did that because their thought was, like everybody else, give these animals more protein, animal protein, give more animal protein, they're less likely to get cancer. That's what their thought was. They saw these results. The ones getting more animal protein dramatically, 100% got the cancers. The others getting the lower protein did not. I mean, you can hardly beat those numbers. They're really pretty spectacular. They didn't believe their own research, I should say. And they didn't go down that path because it was kind of sacred in India at that time, too. To consume dairy, so they didn't want to challenge that idea, but they went about the research to show that it may be the opposite. And so that's when I really got our work program going. And I'm going to show you here, I could show you lots of slides on this. I don't want to sort of bore you to death on that, but I do want to show you one. One of the results that we got in the first 3 or 4 years or so that really, all of a sudden I had to think to myself, this is true. Animal protein is not what we want. What I'm showing here is a little chart showing the development of cancer. That's on the y-axis, right? Development of cancer as a function over the first 12 weeks. There was a gene mutation. All cancers start mutations, okay? So they all had the mutation to get liver cancer. However, ones fed the 20%, like the Indian workers did, once I walk it back there again, those cancers were growing well in the first 12 weeks. The ones fed 5%, they weren't growing. They started out with the same place. But they all had the same sort of mutation to cause that cancer. But only the ones that consuming animal protein, there the cancers grew. That's sort of confirming what the Indian workers had done. Then there was this thing here, and this is really a significant part of this story. I wanted to see what would happen if we changed the diet during the course of that 12 weeks. Okay, feed them 20%. Let's just switch it to 5, see what happens. On, off. And so we did that. Here's what we saw. I mean, this is dramatic. We could turn cancer on and off by just adjusting the protein level. Animal protein. Give more animal protein to cancer grow. Switch it to plant protein, turn it off, or decrease I mean, it was so dramatic. And that, I'd say, it really got me on board with changing my own thinking, quite frankly. And it's not the idea of using animal protein to make people well or feed the kids and stuff like that. That just was not the way it goes. That led, incidentally, that observation there really challenged the way we even think about cancer in a very large context. You've heard it before, you know, we tend to get cancer, so the story goes. It's in our families, right? It's a genetic thing. The cancer industry and the cancer research community, that's what they all say. You can look on the websites of the leading cancer industries. They say cancer is a genetic disease. They want us to believe, I mean, almost innocently, as part of the paradigm, they want us to believe that cancer is a function of our genes. And it is, because cancer starts with a changed gene. But what we were showing here, we can have all the genes that might give rise to cancer, a few other things, all our lives. But whether we do or don't get those diseases is a function of what our nutrition is going to be. Bottom line, eat plants. You don't want to turn all those nasty genes that might be present in our bodies from time to time. We tried plant protein over these years and tried soy and wheat, for example. They didn't turn the cancer on, and even when it's fed at the 20% level. Can you imagine that? I mean, there's a huge difference. Here's animal protein pushing cancer, and here's plant protein doing nothing. That is pretty exciting, to say the least. Of course, I then became interested in wanting to know, there's this phenomenon which nobody seems to know, and people want to refute it. I was warned, don't go down that path. You're going to get yourself in trouble. That was, and I did get myself in trouble many times over. But in any case, I particularly wanted to know if this is true here. It's in experimental animal studies. Is it true in humans? That's one of the questions. The other question is, is it true for other diseases? So that's what became the whole program. And the bottom line is, without getting in all the details, yes. When we eat animal food to get that protein, less plant foods, that's when we get these diseases that killed 90% of us before our time. It's that simple. So I wanted to show you. My wife gets a little bit excited about this. I go too much into too much detail, but I want to show you this story because it's a picture. Here's a normal cell, green cell, cancer cell, okay? I want to show you just the very simplest of the simple relationships, how a normal cell gets turned into a cancer cell. Keep in mind, we've got about 30-some trillion cells in our body. 30, that's a number you can't even imagine. And every cell is like a universe. There's so much going on in there. I'm going to show you here what happens on a normal cell as it becomes cancer cell, okay? There's a chemical on the outside, like environmental chemicals and stuff. On the outside, we get exposed to carcinogens. They come in and we absorb. They get into our cells. They start causing cancer. That's C. That's a carcinogen getting into the cell. When these chemicals come into our cells, they're metabolized then by some enzymes. One in particular, that's the MFO enzyme. The purpose of that, when our body sees that, when our cells see a nasty chemical come in like that, the first thing it wants to do is get it out of here. So the enzyme is there, detoxifies it. But in that process of that going on, there's a little bit of spillage here. There's a kind of a hot, one of the products is not less toxic. It's actually very, very active. It's called epoxide, for any of you in the science area. And that is so hot that what happens, it goes and it zaps the DNA and causes damage. That's how we get cancer. The chemicals come in and they go into the cell and they kind of get changed around, and one of the products is produced, only about 1/1000th what the other is. It hits the DNA and mutates the DNA, okay? That's a damaged gene. Now when it mutates it, that new DNA, that new gene essentially, might lead to cancer of some kind. That's the way the whole thing goes. That's the cancer cell there. But we got a mechanism, we got a fail-safe mechanism in our cells. As this DNA nonsense is going on, is being attacked by chemicals, we got a repair system. That's called the default position, called DNA repair. And it operates really well on us. 99.999% of this kind of stuff going on, our body cleans it out. Good deal. So as long as we have the repair mechanism in place, okay? So, but still, our body fails a little bit now and again. And so that, if that is not repaired, it goes and forms a new cancer. That's the beginning of a cancer cell. Now that gene is there, and that said, hey, I'm able to form cancer. So now that new cell is kind of dangerous. It's kind of sitting there, ready to go. That's the early cancer. Okay, and then it grows over some years, quite frankly, oftentimes, maybe multiple years, gradually grows, and finally that emerges, you see it. And then we get diagnosed with a cancer. So that's my little scheme. I want to just show you here what we did. And I think this, from my point of view, this is, I think, the most exciting thing I think I ever learned. And it really has a way of, I think, shaping our thinking about things. I wanted to know when the animal protein is, we're consuming all this, want to eat this animal protein, and it's doing all this bad, maybe it's doing something bad. If we could find out exactly how it works, maybe, which mechanism we say it is, we can find out which one mechanism accounts for that, that all of a sudden sets us up for the drug industry. That's where the drug industry comes in. Because they look at this kind of thing. If they know the mechanism, we can create a chemical and block it. And then we can all eat our animal protein, go home safe. So we can still eat our animal protein. We'll just take that mechanism, get a chemical, block that, and we're home free. That's what the statins is for heart disease. My friends in heart disease, they don't like me say this too much, but quite frankly, statins is an $85 billion industry. And everybody's supposed to take statins and not get heart disease, right? That all comes out of a system by which the so-called mechanism of cholesterol causing heart disease, so the story goes, that they found the one mechanism. So they made some chemicals. They called them statins. Now, statins do not have the effect, anywhere near the effect, if any effect at all, and actually reduces the risk for heart disease. This diet. It's the same kind of diet I'm talking about here. So anyhow, I was looking for the mechanism for cancer. I'm going to jump in here. See a little asterisk there, a little star on the left with a carcinogen. The first thing we learned was that the high protein diet enhanced the rate of transfer into that carcinogen into the cell. Oh well, that's what it is. We could have stopped there. We said, all we need to do is get a chemical, block that transport. That'd be nice. But then we'd look for another one. I kept getting students working on the doctorates with me, and I'd have to give them a project. So we kind of thinking up things like let's look a little bit more. We found the high protein diet changed that enzyme, so it was more active, and therefore converted more of the cancer carcinogen into the product that zapped the DNA. It did it a couple different ways. I put 2 stars there. I don't want to get into that. And then we get more of the carcinogen bind to the DNA. Now, if you got more DNA being attacked and damaged, we got more cancer, right? That was the idea. So, wait a minute. We got 4 things here. The high protein diet, every single case changed those things in a way to give more cancer. So we went further. Here's a new one. The DNA repair, that's a good thing. We want that around. What does that high protein do? It shuts it down. In other words, turns on all those things, it increases cancer, and then it shuts down a fail-safe mechanism. That's pretty insidious. Same thing happens then when the new cancer cells are coming around. When we get cancer cells forming in our body all the time, but our body is quite efficient in taking care of them, right? A second way it does that DNA repair. But the second way it does, as soon as the little cancer cells forms in our bodies, we have the immune system comes into play. And it produces what are called natural killer cells. Those natural killer cells then go and gobble up the new cancer cells that kills them. And it's another fail-safe mechanism. Beautiful system. So our immune system is always looking out for being able to, help us out on that score. And what does the animal protein do? It blocks the DNA repair. It blocks the formation of natural killer cells. So the 2 things we got going for us, the animal protein shuts them both down. It shuts them down. It turns everything else on. And so it went. I could put 4 more stars there. I won't get into the details. But what really became into play, and I found really fascinating, when we consume animal protein, and for that any other nutrient that's good